Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wa sallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wa sallam. Ameen. Alhamdulillahi rabbil alameen. Partial fractions and binomial theorem combined. Lecture 1. For this lecture, I am using the work of my student Ms. Sharika Batul of class 2020, the Lyceum. An important advice for me and for everyone: we should be fair to others. Here is the list of important questions of this chapter from this book. This is the index of the questions. Index of this book, in fact. The questions are from November 9 to June 16, all variants. Question number 1. Express 5x plus 3 upon x plus 1 whole square 3x plus 2 in partial fractions. And the second part is, hence obtain an expression in ascending powers of x up to and including the term in x square. Part 1. Whenever you do partial fraction, then you need to observe the type of fraction. This is proper fraction, because the power of the highest power of the variable in numerator is less than the highest power of variable in denominator. So the fraction is proper. Number 2, you need to observe the type of factors. Here are two types of factors: repeated linear and linear. Repeated linear factor is written twice, once with power 1 and then with power 2. And since all factors are linear, therefore we must have constants in numerator. I'm sorry. And then you should find the values of x from the given factors. So from this factor, the value of x is -1. From this factor, the value of x is -2 upon 3. And now you need to substitute these values one by one into this equation, this one. So by substituting -1 into this equation, you can easily get the value of b. And then by substituting -2 upon 3 into this equation, you can easily get the value of c. This is b. This is c. And for a, you can suppose any value of x which will make the calculation simple. So the best value of x is 0. So by supposing x 0, we can have the value of a, which is 1. After getting all the values of a, b and c, substitute all the values back into this equation. Say equation number 1. Substitute all into equation 1. So this is the right partial fraction, the required partial fraction. I'm sorry. Part 2. Hence obtain the expansion of this in ascending powers of x up to and including the term in x square. See, this expansion has power 1, this expansion has power 1, so we can use the rules for expanding these expansions. And since this expansion has power 2, therefore we have to use the theorem, the factorial form of the theorem for this expansion. You must watch all my lectures on partial fractions and binomial theorem on YouTube on my channel, so that you will understand the concepts in detail. So when we will use the rule of 1 plus x minus 1 onto this expansion, we'll get this result. And here we have to use the theorem because power is not -1. The rule is for negative power 1. When the power is -1, we can use the rule. Otherwise, we always use the theorem, the factorial form, to expand the expansion. and here we use the rule to expand this expansion. The theorem is copy the first term, then this is n upon 1 factorial, and the second term has power 1. Then this is n minus 1 over 2 factorial, and second term has power 2. And then you just need to simplify this. Make sure you avoid careless mistakes while simplifying the things. This is the final answer. If you will use the rules for this expansion and for this expansion, then you will save your time in exam. If you will use factorial form for this and for this, that will waste your time. So make sure you understand the rules from my lectures on YouTube on this chapter, Binomial Theorem. Question number 2. Here we have a different factor in denominator. It's a quadratic factor, but the fraction is proper. Proper fraction with quadratic factor. So we have to split this fraction into 2 fractions, and one with a linear factor and the other fraction with quadratic factor. Whenever we have quadratic factor, we write linear factor in denominator, in numerator, like this, bx plus c. Now you just do just multiplying both sides with this denominator, you can get this thing. We always get this thing by multiplying both sides with this denominator. Well, the next thing is get the values of x from these factors. From this factor, the value of x is 1. From this, no value, no real roots. From quadratic factor, you will always get no real roots. I mean, you will never get a value of x. So whenever you get no real root, always suppose x 0 to make this constant 0. So from quadratic factor, we will never get any value of x. So we will always suppose x 0 to make the calculation simple. So first substitute 1, because we got this value from this factor, and by the help of this x1, we will get the value of a. Now substitute x0, which we suppose for from quadratic factor. Therefore, by substituting x0, we'll get c. The value of c is minus 1 upon 3. Make sure you always suppose 0 for quadratic factor. Now you have option. You can suppose any value of x for the constant b, but suppose that value of x which will make the calculation simple. So the easier value is 2. This is the easiest value. This will make the calculation simple. Avoid supposing negative values like minus 1. Minus 1 is okay, but negative sign makes the complications. So by substituting 2 into this equation, we can get the value of b. It depends on your algebra. If you have enough practice, then you can easily handle these calculations in no time. And after getting the values of a, b and c, substitute all into this equation. Make sure you substitute the values into this equation. If you won't substitute the values into this equation, you will lose 1 mark. This is the answer of partial fraction, part 1. Now the second part is very simple. With the help of the rules, we will expand this expansion. So this is one of the easiest way to solve the question, this question or questions of these types, because the expansion has power -1. So when the power is -1, we always use the rules to expand the expansions. When we have negative sign, according to the rule, all signs will be positive. When we have positive sign, according to the rule, for negative power 1, the signs will be alternate. Well, after simplifying this, we can get this this equation, and then finally we will get the answer. So the important step is this. These two steps are very important. Make sure you use the rules correctly. And the rules are for only negative power 1. Let me write the rules here. There are two rules for -1 power. When we have positive sign, then we expand the expansion with alternate signs. This is the rule number 1. I'm sorry. And when we have negative sign with power -1, then we expand all the terms with positive signs. These are two rules, and these rules we use in partial fractions, binomial in partial fractions. The use of partial fraction in binomial, in fact. We use partial fraction to expand this expansion, the expansion of part 1. Now the next question is question number 4. This is the question of an improper fraction, because the power of the highest power of the variable in denominator is same as the highest power of the variable in numerator. The highest power of the variable in denominator is 3, and the highest power of the variable in numerator is also 3. So this fraction is improper, and improper fraction always starts with a constant, and this is the repeated linear factor, so this will be b upon x, c upon x square, and this is the linear factor, so d upon 2x minus 1. We write the repeated linear factor twice. So the part 1, we just need to multiplying both sides with this thing, with this denominator, to eliminate this fraction and these fractions. So by multiplying both sides with this denominator, we will get this thing. We have this equation. Now get the values of x from this equation, from these factors, from here x0, from here x half. x0 and x half. Well, we always find the value of this constant by comparing the coefficient method. So when we will check the coefficient of x cube onto right hand side, then it will be 2a, and the coefficient of x cube on left hand side is 2. So we just need to equate the coefficients of highest powers of x on both sides for this constant. So therefore a is 1. This is a way to get the value of the first unknown constant in improper fractions by comparing the coefficients of highest powers of x on both sides. We can easily get the value of this constant, and this is the best way to save the time and to solve this type of question. The rest is same. We will find the values of b, c and d in the same way as we did in proper fractions. So by substituting x0 into this equation, we can get the value of c, which is 1, and by substituting x positive half, we can get the value of d. Now just one constant is left, which is constant b. For that we can suppose any value of x, but suppose that value which will make the calculation simple and save your time. So x1 is the best value, therefore b is 2. Hence this is the required partial fraction. Make sure you substitute all the values of the constants into equation 1. This is equation 1. The second part is of integration. It's very simple. You just need to use basic formulas to integrate this expansion. This function 2x cubed minus 1 upon x squared 2x minus 1. Now the next question is 7. This is just of binomial distribution, binomial theorem question. Whenever you use binomial, make sure the first term must be 1. If not, then make it 1 by taking common. Since this is 1, so there is no problem. You can easily expand this by using the theorem. And the theorem straight says copy the first term 1 and then write n upon 1 factorial and the second term with power 1. Then n minus 1 over 2 factorial, second term to the power 2. That's it. Just need to simplify this. Question 8 is similar to question number 7. You just need to use theorem to expand this. This is the cube root, so this will become 1 upon 3. And it's very simple to expand the expansion through the theorem by using the theorem, the factorial form. But it requires a lot of practice. Maths is the combination of two things: detailed concepts, comprehensive concepts, and regular practice. You cannot learn maths without practice. You cannot be good at maths without practice. So make sure you practice as much as you can. I'm sorry. This is a very good question. In this question, we have to expand this expansion up to and including the term in x square. So the first thing, the best thing, the most important thing for binomial theorem in P3 that the first term of the expansion must be 1. If not, then make it 1 by taking common. Since this is not 1, so we have to take this 2 common. So when you will take this 2 common, it will become 2 square, and this fraction will become 1 plus x upon 2. This function in fact will become 1 plus x upon 2. 2 plus x whole square. C. Take 2 common, so you will get 1 upon x, 1 plus x upon 2, and whole power is 2. Give this power to both the terms, so this will become 4, 1 plus x upon 2, power 2. This is the way to take the common. Make sure you take the common in denominator in order to make the calculations simple and easy. If you will bring this function in numerator and then you will take common, then this will become very difficult. So try to take the common when the power is positive in denominator. Now you just need to simplify this thing, and then you just need to expand this part. You have to use the theorem. And according to the binomial theorem, you need to copy the first term and then copy n upon 1 factorial, second term with power 1, and n minus 1 over 2 factorial, second term to the power 2, and then just need to simplify this. Now the next question is question 13. An improper fraction. So here you just need to first make the partial fraction. Just need to split this in an improper fraction. And when we have improper fraction, we start the fraction with a constant. So this fraction can be split into this fraction, a plus b upon linear factor, c upon linear factor. After splitting the fraction correctly, you just need to get the values of x from the factors. From this factor, the value of x is minus half. From this factor, the value of x is minus 2. But we find the value of this first constant through uh, comparing the coefficient method. For this constant, we compare the coefficients of highest powers of x on both sides. So by comparing the coefficients of highest power of x on both sides, we can get the value of a, c. When you will multiply these three terms, you will get 2ax square. And the coefficient of x square on the left side is 4. Therefore, 2a will be 4, hence a will be 2. This is the best way to get the value of this constant. Well, for b and c, you just need to substitute these values one by one. So by substituting x minus half, we can get the value of b, which is 1. And then we just need to substitute minus 2 to get the value of c. This is the value of c. Just leaves this part. I already have explained how to get the value of a. And now substitute a, b, c into this equation. This is the final answer, the required partial fraction. I'm sorry. This is a very good question of binomial theorem. You just need to expand this question carefully. First, you need to distribute the square root to both the functions, this and this. And then you need to expand this separately and this separately. Both are multiplying, so make sure you do this calculation very carefully. So after expanding and then multiplying both, you can get the answer. Again, a lot of calculation is involved, therefore practice as much as you can to handle these type of questions in no time. The next question is 15. This is a very good question. Here you have to take this 4 common, because you have to make the first term 1. So when you will take this 4 common, this is a complicated way of taking common. I avoid this way. Let me show you how to take common in an easier way. So we have 1 upon 4 plus 3x. We can write this as 4 1 plus 3x under root. So this will become, this will be 3x upon 4. So when we will bring this 4 outside the root, it will become 2. And we have root here, 1 plus 3x upon 4. You all know square root means power negative half in numerator. Finally, we have half 1 plus 3x upon 4 to the power negative half. This is the best way to take common. So after getting this thing, you can expand this expansion through the theorem, which is here. This is n upon 1 factorial, second term power 1, n minus 1, 2 factorial, second term to the power 2, and just simplify this. Taking common is very important. Make sure you take the common correctly. Again, we have a question of improper fraction, and you all know how to get the values, how to split this type of fraction. See, you just need to write constant first, because improper fraction always starts with a constant. So a plus b upon x plus 1 plus c upon 2x minus 3 will be the required fraction. So therefore we have 4x square minus 7x minus 1 is equal to this and this. Make sure you start the improper fraction with constant. And you know how to get the values of ABC. From this factor we have x minus 1, from this we have 3 upon 2, and we find the value of the first unknown constant by comparing the coefficients of the highest powers of x on both sides. This is 4, and when you will multiply these two, you will get 2a x square. So 2a will be equal to 4, therefore a will be 2. And after getting the value of a, substitute these values, minus 1 and 3 upon 2, 1 by 1, to get the values of b and c. So this is the final answer. Always find the value of the first unknown constant in improper fraction by comparing the coefficient method. This is the binomial question. This is very simple. You just need to expand this part of the expansion through theorem by using the factorial form of the theorem, and you just need to handle the calculations carefully. Avoid careless mistakes. Do these calculations carefully. Avoid the shortcuts as well. If you avoid the shortcuts, then you will be able to avoid the careless mistakes. Sorry. Well, this is all from this lecture. I hope this lecture would help you all to understand the way to solve the questions of binomial and partial together, and binomial binomial theorem questions separately, like this question 19. I'm going to end the class over here, finish this class here with this advice for me and for everyone. And the advice is, don't be overconfident. Allah Hafiz.